and gentlemen, my name is Carrie Weaver. I did my Math 4950 project on the bus driver's sanity problem, and my wonderful advisor was Dr. Ben Rushing. Okay, the bus driver's sanity problem deals with a bus driver who, while he loves kids, he loves his time, a combination of kids and times, not so much. It actually goes so far as to comparing screaming kids to radiation. So a large amount of kids for just a short amount of time is more dangerous than just a little amount of kids for a longer amount of time. So the bus driver is not really concerned with how long he actually has to drive the bus. He's more concerned with how many kids are on the bus for how long. Okay? So his routes are going to be measured in kid minutes being the amount of kids on the bus multiplied by the number of minutes the kids are actually on the bus. So therefore, the bus driver seeks a route that will minimize his amount of kid minutes. Okay? And he only has a couple of rules he has to follow. One rule is that from the school, he can choose a direction to go, but he must stop at the first stop, which means he can't pass up a stop without letting off the kids that are to get off there. And then he will proceed to the rest of the route. Okay, so of course he's seeking a route that minimizes the sum of all of his kid minutes. So say for instance there are 3 kids on the bus. 2 kids are on the bus each for 10 minutes with 1 kid on the bus for 12 minutes. That would give us a total of 32 kid minutes. Okay, in our first example, I'm going to show you a road where the bus driver starts at the school with 12 kids on the bus. And so if he was to go left for 2 minutes, he would drop off 8 kids at his first stop, and so on. Okay, so our first possible route, the bus driver is going to choose to go to the right to begin with. And it'll take him 7 minutes before he drops off 3 kids at his first stop. And that's going to automatically add 84 kid minutes. Okay, then he's going to go back right for 9 minutes with 9 kids on the bus, and that'll give him 81 kid minutes. And then he'll continue going back to the right, and that's going to add 6 kid minutes. So this first route will actually total in 171 kid minutes. So now we're going to look at the other 2 possible routes. Route 2, as you can see, he would go right, then back left, and then back right again. And then that would give him a total of 75 kid minutes. And then in the third route, he would go left, left, and then back right. I think I said that backwards. And that's going to give him 93 kid minutes. So here's looking at all the routes together. You'll notice that the second route actually took the most amount of time, but it actually resulted in the optimal route, which was the least amount of kid minutes. Okay, so now we're going to consider this problem. During the summer, a bus driver who works for a K through 1st elementary school hears that he has been assigned a bus route on a road with only east and west directions. There will only be 2 stops in each direction, but he does not know how many kids are going to be on the bus, and he does not know how many minutes between each stop. He also heard that these are the worst kids in the school, and he wants to be exposed to the least amount of kid minutes as possible because screaming kids make him insane. And he calls his local college and he hires a math student to create a formula that will allow him to plug in his numbers and spit out his optimal route. So it's important for us to calculate the possible routes. And we see that the bus driver has 2 stops to the east and 2 stops to the west, giving us 4 stops. So we do the math on this, and since we count the stops to the west as being the same because of the direction they're in, and the same to the east, we'll make these calculations and divide 4 factorial by 2 factorial, 2 factorial, which will give us a total of 6 possible routes. And here are the routes, and this would be the bus driver would choose to go west, then east, then west, and so on. Okay, so here is the first formula I created, where M of K is the total amount of kid minutes for this route. K is the number of kids to begin with on the bus going for M sub 1 minutes to the first stop to the west. Then you would add, of course, how many kids are left on the bus times the amount of time it takes to get back to the first stop to the east, and then so on. And this part right here is how many kids are remaining after all other stops have been made times the amount of minutes from one end of the stop to the other. But I want to simplify this formula by letting capital M equal the time it takes to get from one end of the route to the other. And M of K, of course, is the final amount of kid minutes. And also, in every route, after all stops have been made, and there's just one stop left to be made, the remaining kids will either be K2 or K4, which is the amount of kids that get off at the end stops. Okay, so here's another formula after I use the capital M and the K2 at the end. And this is for the west, east, east route. East, east, west, west. West, east, west, east. East, west, east, west. And east, west, west, east. Okay, so I thought it would be a great idea to put all these formulas into a spreadsheet, so that, which is what the bus driver wants. And I started putting in all kind of different values for the numbers, and I kind of noticed some patterns where I could never make the backtracking routes, the routes that had the most amount of backtracking, which are the east-west, east-west, and the west-east, west-east. Those routes have the greatest amount of backtracking. I started noticing that I could never make these routes be the optimal route. I got it close here. It came in second place. So I thought it would be reasonable to state that given a road with only east and west directions with 2 stops on each side of the school, then the route involving the most backtracking will not be the optimal route to reduce the exposure to kid minutes, which you would think would make sense. So we're going to just look at these 2 routes. We're going to look at the route with the most amount of backtracking compared to the route with the least amount of backtracking. Okay, and we're going to let the total amount of kid minutes for the east-west, east-west route equal X, which equals this. This is the formula after I took out all the subtraction, and I took out all the simplification, and I combined like terms, taking the minutes, so that each part of the equation is in kid minutes. And here it is for the east, east, west, west route. And Z will actually equal the amount of kid minutes for this route. So I thought, okay, so if I can show that X is greater than Z, then the EW route could never be the optimal route. So here's X minus Z. Gives us this formula here. So what I'm needing to prove is that the red part of the equation is actually greater than the green always, and if it's not, then if the red part of this is less, if it actually is less than the green part, then the backtracking route can be the optimal route. And here, so I just assigned the M, the K, the M and the K's with just different values. And I noticed that when I got to K1, that was my key factor in saying, okay, is it possible for my green to actually be greater than the red? And it ends up that, in fact, yes. But it wasn't until I actually took these 2 equations and subtracted them that I actually found out that the east-west, east-west can be the optimal route, and that the east, east, west, west, in fact, is the worst possible route. Then I thought, well, what can I do for the bus driver? How can I help him? But I think I figured out, well, I know I figured out that he just needs to study this in a he just needs to look at all of this in a case-by-case study by putting it into the spreadsheet like we've done. And, but there are similarities in the routes that can reduce the amount of calculations the bus driver needs to make. So if you look at the routes that begin when he chooses to go west first, since he chooses to go west first, those number of kid minutes will always be the same. And in our first two routes up here, actually the first two stops in those routes, the kid minutes will equal the same amount. So all we really need to look at is the last two parts of the route, the last two stops. And if we compare those two stops and we throw out the larger route, and then we have to go back and we throw out the larger route, and then we have to go back and we take the minimum of the two and compare the last three stops together, and then we can actually reduce, we can then compare the smaller of those two routes with the west-west-east route, and reduce the amount of calculations the bus driver would need to make in order to find his optimal route. Similarly, we could do the same thing with the east routes. But in conclusion, the best way for the bus driver to do this is to do what he did and put all the formulas into an Excel spreadsheet. Questions? Any questions?
Yes, we're gonna take a break after this. I mean,
Take a break
questions for
before
Carrie?
this. No questions?